Got 2 problems from the sprint round for you today, and you know what that means. Sprint round. We should be able to do these fast. Let's check these out. Start with the one on the left here, geometric sequence of positive numbers. The 5th term is 11, and the 11th term is 5. And we have to find the 8th term. And this is a geometric sequence problem. We know how to handle these. We've got formulas, formula sheets right here. We've got a formula for terms of a geometric sequence. I remember where that is. It's on this page. There it is. There it is. There's my formula. A times r to the n minus 1. And, what are a, r, and n? Let's see here. Oh, a is the first term. R is the common ratio. Common ratio? Oh, that's right. Geometric sequence. That's where you multiply by the same thing over and over. So if you start with some number, a, and we're going to multiply by r over and over, well, the first term is a. The second term is a times r, because we just multiply by r. Then we multiply by r again to get the third term. So the third term is a times r squared. Fourth term is a times r cubed, and so on. And that gives us our formula. Whenever you get to the nth term, you have a times r to the n minus 1. Because you have to multiply by r n minus 1 times to get there. Great. So now that we know why our formula works, let's see what we can do with it. Put the 5 in for n, a times r to the 4th. We know that that is 11, and we know that the 11th term is 5. So we put 11 in here. You get a times r to the 10th is 5. And now I have no idea what to do. Formula sheets. Maybe I got formulas for equations like this. I don't have a formula. I don't have a formula. But I do have a trick. Watch this trick. If I just divide these equations, I cancel out the a's. And over here I have r to the 4th over r to the 10th is 11/5. And I can simplify this. I can cancel some, and I'll end up with 1 over r to the 6th equals 11. Uh-oh. I mean, I could flip these over, and I'll still have a fraction, and everybody hates fractions. Then I'm going to take the 6th root of that fraction, and I'm still not done. I'll have to take that, put it back up here, get a, and then I still have to answer the question. I'm stuck. Formulas. Fail. I'm going to put these away. Let's see, what are we going to do with this? Well, I'm going to go ahead and erase this. And I'll leave the formula up there, and maybe it'll inspire us. Think about, well, that formula was true because that's just what a geometric sequence is. We're just multiplying by the same number over and over again. Aha! We don't really care about the first 4 terms. We know what the 5th term is. And if we start from the 5th term, I'm going to write that down here. It's 5th term, which we know is 11. And then we're going to multiply by the same thing 6 times to get all the way up to the 11th term. Let's go ahead and draw that out. Since it gets 6th term, 7th term, 8th term, that's the one we want. 9th term, 10th term, 11th term. And we know that that's 5. It's a geometric sequence, and we know how that works. We just multiply by r each step of the way. So the 6th term is 11 times r. 7th term is 11r squared, 11r cubed. There it is. That's what we want, 11r cubed. 11r 4th, 11r to the 5th. And then we multiply by r one more time, we'll get that 11th term. So we know that 11r to the 6th equals 5. Uh-oh. If I divide by 11, I'm going to have r to the 6th equals 5/11, so I got the fraction in 6th root, and stuck again. Well, let's forget about all this stuff we know. Let's think about what we want. That's, sometimes when I'm trying to solve problems, just think about what I want really bad. You just think about what you want, and poof, you get it. Let's see if that'll work here. The 8th term, we know what that is. That's 11r cubed. 11r cubed. You're going to think about it really hard. Think with me. Think with the 11r cubed, 11r cubed. Well, we know what 11r to the 6th is. And r to the 6th is just the square of r cubed. Aha. So if we square this, we have 11 squared times r cubed squared, that's r to the 6th. And we know how to figure this out. We've got 11 times r to the 6th already. To get 11 squared r to the 6th, we just multiply by 11. 11 squared r to the 6th, we just multiply both sides of this by 11, is 55. And I know that this is just the square of the 8th term that we wanted. 11 cubed squared is 55. And now I just take the square root. I take the square root, and we know all these numbers are positive. all the numbers in the sequence, and we get 11 times r cubed is the square root of 55. Now that's interesting. The term that's exactly in the middle here between the 5th and the 11th term is the square root of the product of the terms. Is that just a coincidence? You see if you can figure that out. While you're thinking about that, I'm going to move over here to the other problem. We've got A, B, C, D, positive integers. A, B, C make an arithmetic sequence. B, C, D makes a geometric sequence. And we're told that C divided by B is 5/3. We want to find the smallest possible sum of A through D. Now, we could pull out the formula sheets, but we saw what happened last time we tried that. So we're going to put those away. And we're going to do the same thing we did over here. We're going to try to just think about what these sequences actually are. We're going to start just by noticing that C over B equals 5/3 means that C is 5/3 B. Now let's see, we'll take a closer look at our arithmetic sequence. And that's A, B, and now I know that C is 5/3 B, so I'm just going to put that in. 5/3 B. Then we think about what is an arithmetic sequence. Arithmetic sequence is you just take the same size step each time. 1, 3, 5, 7. So here, we know what the size of the step is here. When you go from B to 5/3 B, you're going up by 2/3 B. So A must be 2/3 B back from B. It must be 1/3 B. And now we know our arithmetic sequence is 1/3 B, 1B, 5/3 B. Let's try the same thing for our geometric sequence. We know that we've got B, we've got our 5/3 B again. We're just sticking that in for C. And then D. Geometric sequence, we multiply by the same thing each time. So here we know what we're multiplying by. We multiply by 5/3 to take that first step, so we have to multiply by 5/3 to take the next one. And 5/3 times 5/3 is 25/9. So our geometric sequence, B, 5/3 B, 25/9 B. And now, finally, to get the smallest possible A plus B plus B plus C plus D, we know all of them in terms of B. We just have to pick the smallest B that makes all of these integers. So we want to wipe out all the fractions, and we like wiping out fractions. We're going to pick B to be 9. We can't pick anything smaller than that. When we make B 9, this becomes 25. This is 15. 9 divided by 3 is 3. 3 times 5 is 15. B is just 9, and then our A is 3. And sure enough, 3, 9, 15, that's the arithmetic sequence. 9 times 5/3 is 15 times 5/3 is 25. We add them all up. 25 and 15 is 40, plus 9 plus 3. That is 52, and there you go. No fancy formulas, no tricky algebra. Forget these formula sheets. Formula sheets are for the weak.